Hello friends, in the last video you watched, we talked about investigating the derivatives of exponential and logarithmic functions, and today I'm just going to walk you through, or in this video, I'm just going to walk you through the algebraic representations of those derivatives. So let's get started. Now there's a lot of notes in the background in here. I did those in that graphic lesson, so you don't have to worry about them here. So what if I wanted to take the derivative of e to the x? Well, graphically, we figured out that e to the x is its own derivative, which is really cool. That doesn't happen often. So the derivative of e to the x is e to the x, end of story. But I don't always have e to the x. Sometimes I have e to the u, where u is a function of x. So if you want to cross this u off and call it f of x, that's totally okay. All right, 100% okay. But the derivative of e to the f of x is going to be itself times the derivative of the exponent. So the derivative of e to the f of x is e to the f of x times f prime of x. If I had left that as e to the u, I could use like that chain rule and say that's going to be e to the u du dx, which really means the exact same thing. It's the original times the derivative of the exponent. I just think the f of x notation is probably easier for you to understand. Now, what if instead of e, I have like 4 to the x and I want to take the derivative? Well, then we're in a different place. So I want to talk about what the rule is, and then I'll give you the backstory as to why it is. So if I have the derivative of a to the u, where a is a number, okay, and u is a function of x, let's do the same thing we did before and change that to a to the f of x. The derivative of a to the f of x starts just like the derivative of e to the f of x. It's going to be itself times the derivative of the exponent. And then there's one more multiplier. We also have to multiply by the ln of the base. All right, so the derivative of a to the f of x is a to the f of x times f prime of x times ln a. So for example, if I wanted to take d dx of 4 to the x, it would be 4 to the x times the derivative of the exponent times the ln of the base. So 4 to the x times ln 4. If I had to take the derivative of 6 to the 3x plus 1, that derivative would be itself times the derivative of the exponent times the ln of the base. That's what that rule means. Now, why is that rule the way it is? I will show you. Now, what I'm about to do is nice to know. It's not what I would call need to know, but you should understand it when I go over it. So let's say I have like y equals 4 to the 2x. What I could do is I could rewrite that as y equals e to the ln 4 to the 2x, because e to the ln 4 is 4, right? E to the ln 4 is going to be 4. So all I did is I rewrote 4 in a different form. And then I'm going to use the exponent laws to say if I raise a power to a power, I can multiply the exponents. So this is e to the ln 4 times 2x. If I want to take the derivative of that, the derivative of e to the something is itself times the derivative of the exponent. The derivative of ln 4 times 2 times x is just going to be ln 4 times 2. Okay, Mrs. Weber, how does this help? Well, here's how it helps. When I go to look at this, I can say, wait a second, e to the ln 4 times 2x is really 4 to the 2x, because that's how I rewrote it in the beginning. And then I have times 2 times ln 4, there's the original, times the derivative of the exponent, times the ln of the base. In a nutshell, what that means is the reason the derivative of 4 to the something just has an ln 4 at the end is because you can rewrite 4 to the something as e to the ln 4, and then that ln 4 becomes a coefficient. Okay? But in layman's terms, here's what you need to know about these three rules. Okay? You need to know that the derivative of e to the x is e to the x. Okay? The derivative of e to the x is itself. That comes up a lot. The derivative of e to the f of x is e to the f of x times f prime of x. itself times the derivative of the exponent. And if I take the derivative d dx of any number raised to the f of x, it's going to be itself times the derivative of the exponent times the ln of the base. So itself times the derivative of the exponent times the ln of the base. And there's exponential derivatives. All right, let's turn the page and go to some logarithmic derivatives. So what if I want to take the derivative of ln x? In the previous video, we figured out that the derivative of ln x is just going to be 1 over x. What if instead of ln x, though, you have ln u, or again, we've been changing these u's to f of x's because I think it makes better sense. So if I want the derivative of ln f of x, the rule is f prime of x over f of x. The derivative of an ln is the derivative of the end over the end. So in this example, let's say I have y equals ln x squared. And I want to take that derivative. So the derivative of y equals ln x squared is going to be the derivative of the end over the end. So 2x over x squared, and if you want, that simplifies down to 2 over x. Fun fact, we just said that the derivative of ln x is 1 over x. And we said the derivative of ln x squared is 2 over x. So doesn't that kind of imply that the ln of x squared is twice as big as ln x? Yes, it does, because of the shooting star rule. If I have ln x squared, if you remember, that exponent is allowed to come down in front. Ln x squared is equal to 2 ln x for places where x is greater than 0. So that's one of the reasons that that derivative looks so familiar. All right, and then last but not least, what if it's not an ln? What if it's a log with a different base? It's okay. So what if I have log base b of f of x? The derivative is just like the other one. It's the derivative of the end over the end. And there's one more piece, and we also multiply by 1 over the ln of the base. So it's a lot like that exponential rule where we multiply by the ln of the base, but this time we divide by the ln of the base. So if I wanted the derivative of like log base 4 of x, it's going to be the derivative of the end over the end, and we also divide by the ln of 4. So in a nutshell, here's what you need to know about the forms. D dx of ln f of x is f prime of x over f of x. It's the derivative of the end over the end. Okay, the derivative of the end over the end. If instead of an ln, you have log base b of f of x, it's still the derivative of the end over the end, but also on the bottom, we have the ln of the base. So this one is the derivative of the end over the end, and the ln of the base goes here. Okay, and there's one more thing that I want you to make sure you understand about these rules is when I take these derivatives, your derivative often has a bigger domain than the original, so you only evaluate the derivative on the original domain. Okay, and those are your rules. I hope everybody's having a good day, and I will see you all soon.